Okay, guys, how are you doing? We're gonna solve practical problems regarding voltage division and current division. We have this circuit. So for this circuit, we are asked to calculate the V1 and V2. V1 is the voltage across this branch, the voltage across this 3K resistor, and V2 is the voltage across the 20K resistor. Second, we also asked for power, the power on 3K resistor, and on the 20K, the power on 3K and the 20K right here, the power on both. Also, the power supplied by the power dissipated by these two resistor. Also, the power which is supplied by the source. We only have one source right here, which is a current source. The amount of the power which this current source is deliver. So let's begin. In order to solve this, the asked variables or this question, we have to use current division and voltage division, also Kirchhoff's rules. So first we need to simplify the circuit. As you see, this circuit, we are given 30 milliampere source. We have a resistors right here also, which are in parallel, situated in parallel. So in order to solve the voltage right here, we need to know the voltage across all parallel branches. We need first to calculate the voltage across the node. As you see, this branch, this branch, this branch, and this branch are in parallel. They share the same nodes. We can combine these two resistors as a one resistor, as a one equivalent resistor. Since they are in series, we can simply add them into 4K resistor. So the resultant will be like this, which is, as you see, this branch. First, we simplify it into this one. 3K and 1K is in series. By the way, we can change the position of the branches. Just we can swap the position of the branches when they are in parallel. Just when they share the same two nodes, we can swap the position of the branches. So we can swap this branch and this branch, the combination of these two resistors and the source are in parallel. We swap these two branches, so the summation will be 4K. First, we need to solve the current. So in order to solve the current, assuming this as a closed path, we can use Kirchhoff's current law, which says this current is divided across this branch, and this branch. First, 30 milliampere goes to this one and divided into I1 and IX. IX is also divided into I2 and I3. Because from Kirchhoff's current law, we know that the current entering the junction is equal to the current leaving the junction. So 30 milliampere is simply equal to I1 plus IX. As you see, IX also enter into the junction, I2 and I3 leaves, which is equal to 30 milliampere is equal to I1 plus I2 plus I3. We already know the source current. So we need to find, in order to calculate the voltage across V2, we need to know I3, the amount of current on 20K ohm. So we need to use a current division rule. So by combining two of the resistors, I2 and I3, we can combine I2 and I3 into a single branch. Since they are parallel, so let's combine I2 and I3. The 5K and the 20k ohm, which will be the resultant is their equivalent. The equivalent for the two are like 5 times 20 over 5 plus 20, which is equal to 100 over 25, 4k ohm. So 4k ohm. This 4k is the summation of the two series resistors. So now we simplified this circuit into this one. Now we can simply apply current division rule into this. As you see, this branch is the current on this branch is Ix because it is simplified. So the summation of the two branches is Ix. The current of the summation of the two branches is Ix. So now simply we can apply current division rule. As you know, the current on the branch I1 is, we already know the source voltage is 30 milliampere. So this 30 milliampere is divided between I1 and into this branch Ix. To find I1, we know that to find I1, if we assume this branch as R1, the resistor on this branch as R2, to find I1, we know that from the current division formula. To find I1, the current on this branch, we simply R2 over R1 plus R2 times I source, the I source, which is 30. So both are 4. So 4, these two, R2 is these two, this 4. So 4 over 4 plus 4 times 30 milliampere, which will be I1 is 15 milliampere. If you know I1, since series components share the same current, series components share the same current, V1 will be I1 times 3 ohm resistor. V1 is 45 volt. In order to calculate V2, we need to know the summation of the voltage of these two branch. Because the voltage across these two nodes is the summation of the voltage of V1 and the voltage on this branch. So once the summation of these two is equal to the voltage across this one, and this one, because all the four are in parallel. So simply V2 is 1 ohm times the current on that branch. The current is the same for two because they are in series. So we already calculated I1 times 1 ohm. I1 is 15 milliampere. So 15 times 1, which is equal to 15 volt. V1 we already calculated 45. So 45 plus 15, which is 60. Or the voltage across this branch is equal to the voltage across this branch, also this branch. So simply I1 times their summation, which is equal to 60 volt. Also right here we need to calculate Ix. Ix means the current on this branch, or the current on this branch, or the summation of I2 and I3 is by using current division. Both are equal, so both resistance, the resistance of the both resistors are equal, so the division of the current will be also equal. So this branch also have 15 milliampere, or using current division, assuming this as R2, I2, which is equal to R1 over R1 plus R2 times I source. So 4 over 8, 1 over 2 times 30 milliampere, which is equal to Ix is also 15 milliampere. Now, in order to find I2 and I3, we know that Ix right here, Ix is already 15 milliampere. I1 is also 15 milliampere. So to find I1, I2, I2 is the resistor on the other branch times the resistor on the other branch divided by the summation of the two parallel resistors, 5 plus 20 times the source current or the current which enters into the junction or their common current. Since we know that Ix is I2 plus I3. So using the current division to find I2, we use the other resistor times, so Ix. 20 over 25, which is 4 over 5 times 20, which is equal to 12 milliampere. So if this one is 12, so this one is I2 is 12 milliampere. This one is 3 milliampere because Ix is, we already calculated for Ix, which is equal to 15 milliampere. So the current entering the junction is equal to the summation of the current leaving the junction. I2 and I3 leave the junction, Ix enter into the junction. So if we calculate I3, to calculate V2, we also can calculate V2 on this method, 3 times 20, which is equal to 60. So we need to calculate the power on the 20 volt. The power on 20K is 3 milliampere times the voltage across these two. We know that power is I times V. The current on I3 is 3 milliampere. The voltage across V2 is 60. So the power is 180 milliwatt. Also, the power on 3K is, we know the current on this, the I1 is 15 milliampere. 15 times 3, 15 times the voltage across 3 ohm resistor is 45. So 15 times 45, which is equal to 675 milliwatt. Milliampere times 45 volt, 675 milliwatt. So the power on the source is P source I times V. The voltage across the node is the same for the 4 branch, which is 60 volt. 60 volt times 30 milliampere, which is equal to 1.8 watt. So this is simply how we can calculate. Okay, guys. Now let's come to this problem. As you see, we are this is the circuit, and we are asked to find the V1 and V2, the amount of voltage across this resistor, and the 40 ohm resistor, the amount of voltage V2, and I1, also I1 and I2, the current on this branch and the current on this branch. So in order to solve this V2, I2, and V1, I1, we first need to reduce the circuit, to reduce the circuit into more simpler form. Otherwise, we can't calculate using voltage division or current division. So first, we simplify this circuit. As you see, these two elements are in parallel. Also, these two are in parallel. We're gonna combine these two resistance, and the equivalent resistor will be 12 times 6 divided by 12 plus 6, which is 4 ohm. Their equivalent will be 4 ohm, as you see right here. And the equivalent of these two resistors will also 10 and 40. Their equivalent is 8 ohm, as you see right here. Now we can calculate V1 and V2. This is as you see, this is more simplified form. We can simply calculate this by using KVL. We can simply calculate by using KVL. Also, by using multiple methods. Also, we can calculate by using current division. As you see right here, as you see, I can be calculated. I for this voltage is, first we combine these two are series. As you see, 4 and 8 ohm are in series. We combine in order to find I total. The I total is simply the supplied voltage divided by the equivalent resistor. The equivalent resistor is 4 plus 8, which is 12. 30 divided by 12, which is 2.5 ampere. This is the I total. So now we have the I total. If you have the I total, so this is a series element, so they share the same current. So V1 is simply I times 4 ohm. I times 4 ohm, which is 10, and V2 is 8 times I, which is 8 times 2.5, which is equal to 20. Or we can use a voltage division. As you see, the voltage which is supplied from this voltage is from this source is divided between two resistors, because there is no other element other than these two resistors. So the supplied voltage is divided between two. So in order to find V1, we have a formula. V1 is equal to R1 over R1 plus R2 times the supplied voltage. So the supplied voltage is 30. R1 is, we calculated that R1 is 4 ohm. The summation of R1 and R2 is 12 ohm. So as you see, we can calculate also by using voltage division. The result is the same. The result we get by using Ohm's law or KVL, and the result we get by using voltage division rule is the same. Also V2 is, we can calculate on this way, R2 over R1 plus R2 times the supplied voltage, which is 20, which is the same to the previous method. Okay, to calculate I, we can calculate I. Once we calculate the V1, once we calculated the V1, we can calculate I by using Ohm's law. Simply by using Ohm's law, we have 12 ohm. So V1 is also calculated. The V1 we calculate. Guys, remember, the amount of voltage which reaches across this is always fixed. We assumed that V1, the voltage across the equivalent resistance of two resistors, is equal to V1, because the voltage is always across a node. Parallel components always have the same voltage. That's why the equivalent resistor also have the same voltage as before before reduced. The amount of voltage before reduced. Also, the same works for the current. Let me make it clear. For example, like if you have some source right here and a resistor right here and a voltage, so like multiple resistors like this, so the voltage across this is always the same, whether it is reduced or not. So the amount of voltage right here is equal to the amount of voltage right here, before it is reduced or after it is reduced. So if you are asked to find the V, we can find the amount of voltage after reduced. So we reduce these three resistors, or we find their equivalent resistor. So after that, we find the voltage across this, their equivalent. So the voltage of their equivalent is equal to the amount of the voltage on one of the branch of the parallel components. So keep this in mind. You don't have to necessarily find the amount of voltage while they are in dispersed form. Okay, so the same works for current. If we have this, if we have like this just series components, different series components, the amount of the current before reduction is equal to the amount of current after reduction, or after we find their equivalent, after we find their equivalent resistance. So keep this in mind. In this way we can calculate the amount of voltage by using voltage division and current division. But the current in these branches, are calculated or calculated by using Ohm's law. After we find the voltage, we divide. So in order to find I1 is, in order to find I1 means the current in this branch. So in order to find the current in this branch, we divide V1, because V1 is already calculated. So V1 divided by 12, which is the I1 will be 5 over 6. Also the I2 is the V2 divided by 40. So this is how you can calculate I2 20 divided by 40, which is 0.5 ampere. In order to make sure that your calculation is perfect, you can check it. The voltage across this is calculated to be 10. The voltage across this is 10, and the voltage across this is must be 20, because the supplied voltage is their summation must be equal to the amount of supplied voltage, which is 30.